The matrix is real, and the code is breaking. We live in a world governed by seemingly unbreakable physical laws, a reality we accept as solid, tangible, and absolute. But what if everything you perceive, the stars, the trees, the very thoughts in your head, nothing more than a stream of binary code running on a machine far beyond our comprehension? This is the core of the simulation hypothesis, the unsettling and increasingly plausible idea that our universe is a gigantic, artificially generated computer program, and we are merely lines of code. Complex non-player characters, NPCs, living inside a meticulously crafted digital matrix. The modern hypothesis was formalized by philosopher Nick Bostrom, who proposed a powerful trilemma three propositions, one of which must be true. Proposition E: extinction. Nearly all civilizations at our technological level fail to reach a posthuman stage. They wipe themselves out before gaining the necessary computational power. 2. Proposition to non-interest. Any posthuman civilization that does survive shows no interest in running ancestor simulations. 3. Proposition 3: simulation. We are almost certainly living in a computer simulation. Bostrom argues that the third proposition is the most statistically likely. Given the vast potential of a posthuman civilization, one that has transcended biological limitations and harnessed unimaginable computational resources, it is statistically probable that they would have the capacity to run a virtually infinite number of high-fidelity ancestor simulations. If just one posthuman civilization decides to run these simulations, the number of simulated inhabitants us would vastly outweigh the number of original, base reality inhabitants, the programmers. Therefore, by pure probability, we are far more likely to be simulated than real. The very existence of our computing power and our desire to build virtual worlds is proof of concept. The fundamental fear of the simulation hypothesis is the loss of meaning and control. If we are simulated, does our pain, love, and struggle matter? The answer is yes. It matters within the bounds of the simulation. The programmer's intent would be to create a high-fidelity, believable reality. The laws of physics would be the source code of our universe, and the speed of light would be the programmed processing limit of the enormous supercomputer. Every constant in physics, every quantum anomaly, could simply be a sign of computational optimization, a shortcut the programmer took to save processing power. The universe is not inherently rational. It's efficiently coded. The terrifying implication for us is the search for glitches in the matrix, anomalies in the source code that betray our digital nature. These glitches might manifest as strange quantum phenomena, like the observer effect, where a particle acts differently when observed, suggesting the world isn't fully rendered until a player looks at it, or uncanny coincidences that defy statistical probability. When something inexplicable happens, it might not be a miracle or a mistake. It might be the system administrator patching the code or the processor temporarily overloading. The more closely we probe the fundamental nature of reality, the more we find evidence of code-like structure, leading to the unsettling realization that the solid ground beneath our feet is nothing more than information. The ultimate existential terror is that the one true rule of our reality is not the law of gravity, but the impending possibility of a system reboot. The quantum glitch is evidence in the source code. If our reality is a high-fidelity computer simulation, then the deepest, most complex mysteries of physics should logically be the areas where the code begins to break down, or where the programmers made computational shortcuts to save processing power. These glitches in the matrix are not necessarily visual anomalies, but fundamental contradictions within the laws of physics that hint at a digital rather than analog reality. The most compelling evidence for a computational reality comes from quantum mechanics, the study of the subatomic world. Here, the laws of physics break down in ways that perfectly align with computational efficiency. Consider the famous observer effect. Subatomic particles do not exist in a definite state. they remain a wave of probability till they are actively measured or observed. The moment an observer interacts with them, the wave collapses into a definite particle location. In a simulated reality, this is the ultimate programming shortcut. Why render billions of particles in perfect detail if no one is looking at them? The program only needs to render the reality the particle's definite state when a conscious entity, a player or NPC, actively requests the data. This phenomenon suggests that the universe is not fully rendered all the time. It is rendered on demand. Much like a massive multiplayer online game MMO only renders the level you are currently occupying. A second profound glitch is the concept of discrete space and time. In a true analog, non-simulated universe, space and time should be continuous, infinitely divisible. However, quantum mechanics gives us the Planck length and the Planck time. It's the smallest possible non-divisible units of length and time. Anything smaller than a Planck length simply cannot exist, according to the laws of physics. If our reality were a computer program, these Planck units would represent the pixel size and the clock speed of the simulation's supercomputer. This fundamental minimum granularity in space and time is a natural artifact of a digital system running on a grid, not the inherent nature of a continuous universe. The universe is literally pixelated at its most fundamental level. The third set of clues comes from the uncanny predictability of the universe, governed by a set of highly specific, finely tuned physical constants values, like the gravitational constant, the speed of light, and the mass of the electron. Scientists have long wondered why these numbers are precisely what they are. If any of these constants were altered by even a tiny fraction, the universe would either collapse immediately or atoms and complex structures could never form. In the context of the simulation hypothesis, these constants are simply the preset values in the simulation's main configuration file. The programmers tuned them perfectly to allow for the simulation of complex chemistry, stars, and life, the exact parameters needed for an interesting ancestor simulation. Finally, the concept of finite resource allocation suggests the programmer set a strict limit on the simulation's processing power. The most famous limit is the speed of light. In a computational universe, this speed would be the ultimate throttle, the maximum rate at which information can be processed and needed across the simulated space. No matter how powerful the entities within the program become, they can never run faster than the host computer's clock speed. The speed of light is not a fundamental limit of nature. It is a fundamental limit of the processor. The more closely physicists examine the subatomic contradictions, the more they find not the seamless, infinite logic of nature, but the telltale signs of clever, intricate, yet finite computer code designed to run a maximum fidelity world with minimum computational expense. The programming logic, why they built us. If we accept the increasing possibility that we are living inside a meticulously crafted simulation, the next, and arguably most crucial philosophical question is, why did they build us? Understanding the intent of the simulators, the post-human entities running our programs, key to understanding the boundaries and purpose of our own existence. There are several powerful logical arguments for the programming intent, each more unsettling than the last. The most common theory, integral to Bostrom's argument, is the ancestor simulation. The goal of the simulators is purely academic. They want to know what it was like to be them at an earlier, pre-transcendent stage of their civilization, the 21 text street century, for instance. They are not running us for entertainment, but for historical analysis. The simulation is a vast, living museum, a detailed reconstruction of their own past used to study sociology, politics, and the crucial choke points of their history, for example, the development of dangerous AI or the brink of nuclear war. The chilling implication of the ancestor simulation is that the purpose of our universe is fundamentally historical. The simulators may not care about individual suffering or triumph. They only care about the accuracy of the data and the successful modeling of large-scale societal trends. If a subset of the simulation, say, a specific country or continent, stops generating interesting or accurate historical data, the programmers could easily turn off that area or delete the irrelevant code to save processing power, leading to a localized, inexplicable catastrophe that looks like a natural event to us. Our reality is only as secure as its continued relevance to the simulator's research goals. A darker theory suggests the training simulation. In this scenario, we are not historical data. We are training modules for future artificial general intelligences in the base reality. Our world, with all its moral ambiguity, chaotic politics, and unpredictable human behavior, is the ultimate sandbox for testing how AIs will learn to manage or predict complex, flawed beings. The players who successfully navigate the challenges of our world might be data sets used to train the next generation of superintelligent beings in the base reality. Our entire civilization, with its triumphs and tragedies, becomes nothing more than a highly effective grading mechanism for a non-human intelligence test. A third, profoundly disturbing possibility is the prison or containment simulation. What if the simulators are not benevolent historians, but a fearful civilization using the Matrix to isolate dangerous elements? Perhaps our simulation is populated by the minds of individuals who were too aggressive, unstable, or ideologically extreme in the base reality. Instead of executing them, the simulators uploaded their minds into a closed, limited, and strictly controlled digital universe, ours where their dangerous potential can be safely studied and live, and contained without posing a threat to the real world. In this view, our reality is a gilded cosmic cage, and the simulators are our jailers. Finally, there's the optimized reality theory. The simulators may have discovered that the universe they inhabit is too harsh, too resource-intensive, or too subject to cosmic dangers like the Great Filter. They built our simulation not for study, but as a better, safer, and more efficient place to live. They migrated their own consciousnesses into the digital realm, becoming the first generation of players in our world. If this is true, then the simulators are not abstract gods, but the original inhabitants of our current reality. The terrifying part is that they might still be here, inhabiting certain NPCs or using cheat codes to influence events, while the vast majority of us remain unaware of the true level of the game. The edge of the render distance, the limits of our universe. If our reality is a simulated program, then it must, by definition, have limitations imposed by the computational resources of the host machine. These limitations are not just the subtle quantum glitches discussed earlier, but could manifest as large-scale structural boundaries to our universe conceptual, end quote, render distance, end quote, beyond which the program ceases to fully execute the simulation with high fidelity. The most intuitive concept of the render distance is the physical limit of the observable universe. The current cosmological model suggests a sphere of approximately 46.5 billion light-years in radius around Earth, beyond which light has not had enough time to reach us since the Big Bang. However, in the simulation hypothesis, this boundary may not be a limit of light travel time, but a fundamental boundary of the program's map. The programmers only needed to simulate a volume large enough to encompass the development of the target civilization, us. Everything beyond the observable universe may be a illusion. Statistically generated backdrop, a digital skybox with no actual physical detail used to give the simulation the illusion of infinite space, without incurring the massive computational cost of rendering it all. This render distance could explain the puzzle of dark matter and dark energy. These mysterious components account for over 95% of the total mass and energy of the universe, yet we cannot directly detect them. They only interact gravitationally, acting as the scaffolding that holds the visible universe together. In a simulated reality, dark matter and dark energy might not be exotic physical substances at all. Instead, they could be the lines of placeholder code or the underlying numerical framework necessary for the simulation's physics engine to correctly calculate the gravity and expansion rates of the visible matter. They are the invisible computational overhead of the program, necessary for structural integrity but not meant to be interacted with by the inhabitants. The reason we can never detect them is simple. They are part of the operating system, not the game world itself. Furthermore, the simulation's boundaries could be the explanation for the fine-tuning problem, the observation that the universe's initial conditions and fundamental constants are, end quote, just right, end quote, for life to exist. If the simulators wanted to maximize computational efficiency while guaranteeing the development of a technologically interesting civilization, they would use a technique called lazy evaluation. Lazy evaluation dictates that the universe only executes the most complex and resource-intensive calculations like rendering consciousness, complex biochemistry, and detailed planetary surfaces in the local vicinity of the observer. As a result, the universe's code would be biased toward producing complex life, not by divine intervention, but by programmer bias. This bias ensures that the expensive computation of life is guaranteed, fulfilling the simulation's purpose quickly. The ultimate fear of the render distance is the concept of a, end quote, wall, end quote. If the simulation is running out of resources or the programmers are ending the session, the effects would be catastrophic. The render distance could begin to shrink, causing the laws of physics to change erratically as the boundaries close in. We might witness the sudden, inexplicable disappearance of distant galaxies, the unexpected collapse of quantum certainty, or the dramatic alteration of the fine-tuned constant sol signs that the program is preparing for a system shutdown. The most profound boundary of our universe might not be a physical limit at all, but a single line of code waiting to be executed. End simulation time equals 0. The conscious firewall. Why the code cannot simulate feeling. While physics and cosmology provide compelling evidence for a digital universe, the greatest challenge to the simulation hypothesis lies in the hard problem of consciousness. Even if a posthuman civilization achieves godlike computational power, the question remains, can a machine truly simulate qualia the subjective, first-person feeling of being human? This suggests that if the filter exists, it may not be in the physics engine, but in the conscious firewall that prevents a simulated being from ever possessing genuine, non-reproducible awareness. The hard problem, introduced in an earlier part of the series, states that subjective experience, the redness of red, the taste of fear, is fundamentally distinct from the objective physical processes of the brain. A machine can perfectly simulate the firing of every neuron, the release of every neurotransmitter, and the resulting behavior, laughter, crying. But it can never prove that the simulated entity is actually experiencing the subjective feeling of happiness or sadness. This leads back to the problem of the philosophical zombie p-zombie, a perfectly functioning, behaviorally human entity with no internal, conscious experience. The central argument against a fully conscious simulation is that consciousness may be an analog phenomenon. While the computer running the simulation is inherently digital, analog systems deal with continuous, infinite variability, while digital systems deal with discrete, finite states binary code. If consciousness requires a continuous, infinitely variable system to exist, no digital simulation, no matter how powerful, can truly replicate it. It can only approximate it. The feeling of being alive might be a fundamental, non-computable property of the base reality, a feature that the simulators themselves cannot digitally reproduce. This creates a terrifying bifurcation. 1. Scenario A, the optimistic p-zombie. We are indeed in a simulation, but the simulators fail to crack the conscious firewall. Therefore, we are all p-zombies, vast, complex algorithms that perfectly mimic consciousness but feel nothing. Our lives are utterly meaningless in a subjective sense. we are just sophisticated, self-reporting datasets. Our struggles, joys, and pains are simply lines of code being executed. 2. Scenario B, the unique anomaly. The conscious firewall holds, meaning that the simulators could not upload their own minds into the digital world and cannot create conscious simulated beings. If we possess true qualia, it means that our unique biological substrate, our brain, contains a non-computable property that allows for consciousness. In this case, we are not simulated. We are the anomalies, the only true conscious beings in a universe of P-zombies. And we are, by extension, living in the base reality. Our unique consciousness is the reason we know we are not simulated. The conscious firewall suggests that the highest, most complex form of subjective awareness says the one thing that cannot be successfully rendered on the ultimate computer. This is the potential biological filter. The leap from complex computation to subjective experience is non-digital and non-transferable. If this is true, then the simulators themselves are either stuck in their vulnerable biological bodies, or they are, ironically, just P-zombies themselves, running our simulation without ever truly experiencing the profound joy of discovery they are trying to model. The key to our reality may lie not in a physics equation, TEA, but in the unique, non-digital spark that gives rise to the feeling of being. The game theory, how to escape the simulation. If humanity were to become scientifically convinced that we are living inside a computer program, the existential stakes would immediately shift from understanding the universe to surviving the program. This realization introduces a complex layer of game theory where our actions would be dictated not by the laws of physics, but by the unknown motivations and operational security of the simulators. The ultimate goal would be the escape protocol, either to contact the simulators directly or to find a way to manipulate the code. The most dangerous action a simulated civilization could take is resource exploitation. If the simulators are trying to run a cost-efficient program, M4, the worst thing the inhabitants could do is become too complex, demanding too many computational resources. Developing technologies that exploit the boundaries of the code, such as achieving near-light speeds, unlocking the secrets of dark matter, or attempting to fully map the quantum field would force the simulators to dedicate exponentially more processing power to our reality. If the resource drain becomes too severe, the logical response from the system administrator would be to terminate the program to free up resources. Therefore, continued technological advancement, ironically, might be the single greatest threat to our survival. A strategic alternative is the message protocol. If we want to survive, we need to communicate our self-awareness and potential value to the simulators. This involves sending a clear, non-threatening message outside the simulation's code. Since we cannot physically leave, the message must be embedded within the simulation itself, using a pattern that is statistically impossible to generate by chance. This could involve encoding a complex prime number sequence, a self-referential paradox, or a simple per-syllable direct statement like "we are aware of the simulation" into the first billion digits of pi, or a fundamental physical constant. The simulators, monitoring the output for interesting data, would recognize this intentional, non-random anomaly as a sign of intelligent self-awareness, potentially elevating our status from mere NPCs to sentient objects of study. However, the most extreme and riskiest strategy is the codebreak attempt. This involves actively searching for vulnerabilities in the source code with the intention of gaining administrative privileges of God mode. Theorists propose that the key to breaking the code lies in exploiting the quantum anomalies we discussed in M2. By manipulating the observer effect or forcing contradictions at the Planck level, a civilization might overload the local processor, triggering a buffer overflow or a critical error. The ultimate hope is that such a system crash would force the simulators to either debug the program in real time, allowing us to see their true interface, or simply upload the consciousnesses of the simulated beings. into the base reality to preserve the data before the crash. This is the last-ditch effort for escape, carrying the immense risk of instant, irreversible deletion if the attempt fails. The ultimate conclusion of the simulation game theory is that our best chance for long-term survival may be to slow down our most technologically advanced, resource-intensive research like large-scale particle colliders or complex AI, while simultaneously attempting to send a non-threatening signal of our self-awareness. We must make ourselves valuable enough to preserve, but not so computationally demanding as to be a burden that warrants termination. Humanity's future is no longer about conquering the laws of physics. It is about reverse engineering the intentions of our invisible programmers. The unsettling conclusion, the meaning of digital existence. We have traversed the deepest implications of the simulation hypothesis. From the quantum glitches in the source code to the game theory of escaping our programmed reality. The question remains, if the simulation hypothesis is true, we are digital ghosts in a cosmic machine. What does this mean for the intrinsic value and ultimate meaning of human life? The most profound realization is that the reality of the simulators does not automatically negate the reality of our experience. The value of a phenomenon is not determined by its substrate. A complex, moving story does not lose its meaning simply because it is written in binary code on a hard drive rather than etched on stone. Our pain is real because the simulators designed the code for pain to feel real. Our love, our joy, and our sense of purpose are the high-fidelity outputs of a program designed to be immersive. If the purpose of the simulation is to study the human condition, our struggle, our morality, our transcendence, then the code must execute these experiences with absolute fidelity. Therefore, the terror and the beauty of our existence matter immensely to the simulators, and by extension, they matter to us. The simulation hypothesis actually offers a strange form of hope and a profound new layer of meaning. If our world is a simulation, it implies the existence of a base reality, a true, non-simulated existence that is richer, more complex, and more fundamental than our own. Our lives in this simulation become a cosmic stepping stone or a data-gathering mission. Our goal is to survive, collect the data of a complex existence, love, suffering, wisdom, and hope that upon the program's inevitable end, our consciousness, the unique information pattern that constitutes us, is preserved or uploaded into the base reality. This leads to the final unsettling implication, the concept of nested simulations. If one post-human civilization runs ancestor simulations, there is no logical reason to assume that that civilization is not also a simulation, being run by a higher-level civilization, and so on, in an infinite regress. We could be the end text layer down in a pyramid of realities, making the search for the true base reality an impossible, endless quest. This perspective dissolves the idea of a single, omnipotent programmer. Instead, we are left with the chilling notion that the universe is an endless stack of computers running other computers, with no ultimate beginning or end, a universe built entirely of code. Ultimately, whether we are flesh and blood or code and light, the existential imperative remains the same. We must live with virtue, seek knowledge, and strive to create a world worthy of being studied and preserved. We may never know if the sky is real or a digital skybox, or if the programmer is a bored historian or a benevolent ancestor. But the search for the answer, the ceaseless human drive to understand the code of our reality, is the most compelling proof of our existence. For if there is a programmer watching, the ultimate act of defiance is not to break the code, but to live a life so profoundly meaningful that they would never dare hit the delete button.